again, let's have a look on security of passwords. So explain the difference between social hacking, an attack based on dictionaries, and a brute force attack. So the first one, social hacking, relies on knowing something about a person. You know his nickname, you know his habits, you know his plate on the car, and you can try to make use of this knowledge and find out if this is used as a password. If this doesn't help, then you can go for dictionaries. So there's quite some dictionaries in the internet. Dictionaries of normal words, in Word, Microsoft Word, or dictionaries of football players, or dictionaries of whatsoever. And these and combination of these words you can find there can be used as typical input for passwords as well. And if this doesn't help, and if you don't find any password like that, then the attacker has to go for a brute force attack. Basically, this means he has to try out each and every combination which is possible. And of course, they start systematically. They start with smaller passwords because they are easier to find, and slowly tend to the longer ones. So if social hacking and dictionaries, which is always the first try, if those don't help, then brute force attack is the one to go for. And now, if somebody will go for a brute force attack, how safe is a password? In the end, if you have ultimate time, the attacker will always find the password, because it simply exists and somehow it can be guessed. It's just a matter of time. So the question is it safe enough given there is a certain performance in computer? Is it safe enough, for example, to survive a day, a year, 20 years, and so on and so on? So how does it look like? Basically, we have the alphabet, the characters, the set of characters you're taking for your password, which could be digits or could be characters only or special signs, and the length of the password. And then it's always the size of the password, size of the alphabet. Oops. General formula is size of alphabet. Put it in brackets, by the power of length, or the number of characters in the password. And if you have a little bit intuition in mathematics, you see that the length is more important. It more determines the level of quality. So if you assume the following passwords, for example, informatic, then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 characters. So the strength would be 52 by the power of 10. 52 because we are just using the normal alphabet with 26 characters. If we add the upper ones as well, we have 52, and then we have 10 different characters. Check for the next one. 1, 2, 3, 4, 5, 6, 7, 8. So we have 95 by the power of 8. And you can now calculate which one is stronger. I have to check later on. We will see. But here we have 95 because we have digits, we have special characters, we have small, and we have capital characters. And so on. FB7 Wirtschaft, actually it would be a candidate for social hacking because it is somehow for a student at our department possible that these things are taken. For the last one, and we can then end enter our information from in here, we can go to the web page which I have offered in the lecture and simply calculate the numbers there. So once again, you can see we are on this web page grc.com/haystack.html, and this offers some analysis of your password. So if I enter, for example, Informatik, as we have done before, you can see it has 10 characters. The search space depth, so the alphabet is 52. So we can guess this is the number of possible passwords. And now, having different kind of attack scenarios, it will survive for if it is a guess password, if it is an online attack scenario where you can guess thousands per second, then it will roughly stay thousands of centuries. If you have a normal computer, a normal PC, it will hold for 2.44 weeks. And if you have a massive cracking array with kind of special computers, which is not that special, I must say. So it's not something where you have a supercomputer. It's just something where you have invested in 5,000 euros in some kind of computers with graphical cards. Then it will last not even half an hour. Let's compare it with the other one we have given, 78 /SD capital AS. So now we have 95 characters. The alphabet is bigger. However, the number of characters are smaller. And I just look at the last figure in here. You will see it just survives for 1.12 minutes. So you see the length is more important than the search space. Let's go down a little bit. Yeah, so because what should be clear is it is actually not some strengths calculator. It's just a calculator how many different possibilities exist, and if you have a brute force approach, how long will the password survive. And now just compare these two passwords. Yeah, this and the second one. So the first one looks much better to remember because it consists simply of D0G and then some dots. The second one is really hard to remember. However, the upper one is one character longer. And this character is the one which is really the issue. So the upper one is, in a brute force attack, the better one. Further on, you find some arguments around if this is really some kind of safe, having these only dots ended after, let's say, 3 characters. And the argument is simply if the attacker has no idea what your password looks like, then brute force is the only approach, and then it doesn't matter if you have stuffed your password with simply some dots. Only if everybody would use the same kind of stuffing technique with dots, then it would be critical again, because then the password attacker could assume something and of course would first go for these kind of things. What you should remember is length is important.